Hello students, in this video lecture, I'm going to discuss CFG to PDA conversion. So before I do CFG to PDA conversion, there are two rules that you should know. So first rule is for each variable or a non-terminal A, and the second rule is for each terminal A. Okay, so we know that CFG to PDA conversion, my input will be CFG and my output should be, my final answer should be the transition function. So my input will be given in the production form, because in CFG we are going to write the set of production. So production will be in the form of A to beta, where A represent the left hand side of the production and beta represent the right hand side of the production. And we know that in CFG, the left hand side we are going to have a single non-terminal, and right hand side we are going to have a set of terminal and non-terminal as well as epsilon. So we'll be having a production. From production, because we have to write a push on automata, so we are going to write a transition function. So in transition function, we are going to have three parameters when we are writing a transition function for push on automata. Here the current state, here the input we are reading, and here the stack. Okay, so what is the top of the stack? And then here I'm going to write the next state, and here it will be the stack content. Okay, so from this production form, I'm going to write the transition function for each variable A or a non-terminal, and for each terminal I'm going to write this transition function. So here I'm going to write the current state. Here both second and third parameter will be the terminal which I am considering, and here the same state, and epsilon represent the pop operation. So these two rules you need to remember. Now let us take one example. So here I have a production non-terminal. These are the production, and there are two non-terminal I and E. So we know that capital letter symbols are nothing but the non-terminal. So non-terminals are represented by capital letter symbol, and the terminals are represented by small letter symbols as well as digits, the operators like plus, star and all, and parenthesis, opening and closing parenthesis. So we have listed the non-terminal and terminal here. So the non-terminals are all these non-terminals are I and E, and terminals are this small letter A, B, digit, parenthesis and the operators. Now for any question, this first transition function will be common. So what we are doing here in this transition function, when we always start with the start state. So when we are in the start state Q0, epsilon means we are not reading anything, and Z is there in the stack. Okay, so what we are going to do, we are going to change the state from Q0 to Q1. So my next state will be Q1, and this will be the stack content SZ. So basically what we are doing here, we are pushing the start symbol S onto the stack. So this transition function will be there for any question. So any problem is asked, this transition you have to always write. So my current here my start state, no input, epsilon represent no input, and Z we know that when we are taking pushed on automata, Z is the stack alphabet, so it will be always there in the stack. So Z is the stack alphabet, so I am going to change the state from Q0 to Q1, and I am going to push S onto the stack. So this is the transition function which we are going to write. And then the second the second and third we are going to write for non-term with respect to each non-terminal and terminal using these two rules. Okay, so here I have listed the rules, and I have also written the question again. So now the first rule is for non-terminal. So here what is happening, when we started from Q0 and then we were not reading anything, no input, Z was there onto the stack, and then we just pushed S onto the stack. Previous slide we have seen that. Now I am in currently Q1. So here what is happening, whatever state I have written here, as per this rule, the same state is going to come here, and even we are retaining the same state for the second production, that is for each terminal. So the Q here also, here I am having Q, here also I am having Q. So what you have to do, now I am in Q1. So for both non-terminal and terminal, I am going to retain Q1, and I am not going to change the state Q1. Okay, so here my current state will be Q1, and epsilon instead of A, now one by one whatever productions are given we will consider. So A will be the left hand side of each production. That will be obviously a non-terminal, because in CFG left hand side of each production should be a non-terminal. So that capital A would be a non-terminal. So let us consider first production for I. Okay, so now non-terminal, instead of A I am going to write I. Now right hand side I am going to write Q1 only, because here I have considered Q1, so I am going to write Q1 only. And then here beta would be the right hand side of the production. So right hand side of the production is A. Okay, first production is A, so I'm going to write Q1 A. Second one is I2B. So A is the left hand side of the production, that is I. What is beta? Beta is B, so I'm going to write Q1 B. Okay, then the third one is I2 IA. So left hand side is I, right hand side is IA, so I'm going to write Q1 to IA. Same way, left hand side is I, right hand side is IB for I2 IB production, so I'm going to write Q1 IB. For the same reason, Q1 I0, Q1 I, it's not I0, I0, and Q1 I1. Okay, same way for the second production, when the non-terminal is E, so E to I, when I'm considering, the left hand side of the production is E, the right hand side is I. So what is A here? A is the left hand side of the production, that is E, and what is beta here? That is I. So I'm going to write Q1 epsilon, and instead of A I'm going to write E. Here it will be Q1 I. The second one E star E, so beta is E star E, so it will be Q1 E star E, and then E plus E means Q1 E plus E, and E to E in parenthesis, opening and closing parenthesis, so Q1 E. So like that we have written the transition function using the rule 1 for each non-terminal. Now the second one, for each terminal I am going to write the transition function. So here I am going to write Q1 only. AA means whatever terminal I am having. So we have already listed the set of terminals, right? So once we will write Q1 AA, Q1 BB, Q1 00, Q1 11, Q1 opening parenthesis, Q1 closing, Q1 plus, Q1 star. And here I am going to write Q1 epsilon. For right hand side will be Q1 epsilon only. Okay, so here we are going to write comma. So Q1 AA, Q1 epsilon, Q1 BB, Q1 epsilon, Q1 00, Q1 epsilon, Q1 plus, Q1 epsilon. Like that for other terminal also we will write. And when it is a parenthesis, so for opening also I am going to write Q1 opening. Same way Q1 closing. Okay, closing parenthesis, Q1 epsilon. So using this rule, this is the second transition function we have written. And then this is the last transition function, that also we have to write with respect to each question. So Q1, now we are in Q1, and epsilon here represent end of the input, Z is there onto the stack. We are going to the final state and we are not doing anything. Okay, so the first transition function and the last one will be common for each question. This one will vary, it depends on the question. Okay, so hope you have understood this. Thank you for watching.